So welcome. How's everyone doing this morning? Everyone awake, caffeinated? Caffeinated enough to listen to this for 70 minutes? All right, good. Well, this is the monitoring systems using some open source tools. I'm Randy Saeks. I'm the network manager from Glencoe School District 35. We're located in Glencoe, Illinois. If anyone's interested, you can bug me on Twitter. And make sure if there's anything useful you're finding during the conference, use the hashtag. Share it out to other people that can't be here and kind of get that going. A little bit about my background, and the first thing I want to mention is I put together a Google Doc. I saw that there were some notes being taken in some of the other sessions. So hopefully I tried to get that going. I'm going to have the link on the first 3 slides so everybody can grab it. It's also in the Slack channel in the Dean's Hall 1. That's the space, right? All right, good. I'm in the right place. That's always good. And then I put in there a couple of guiding questions that hopefully we can get some audience participation on so that when everyone leaves, you'll be able to get the information from everyone that's sitting in here, because there's a lot of you in here that have experience, other tools that you probably know of, so feel free to use that. I've been in the K-12 ed tech realm for 16 years now, focused around mostly systems integration. One of the first fun projects I got was making it so that you could sit down to a 10.3.8 or a 10.4.2 Mac and log in with your Novell username and password. And when you did that, there were symlinks and login hooks and all sorts of things so that everything that was on your desktop was actually residing on your Novell server. We wanted to mimic a Windows environment because that's what we did 14 years ago. And things have changed from there to where they are today. That's gotten me to places like this to do conference presentations. I started 2011 was the first time I was able to come to the PSU to present. I've also had some experience with iOS deployment. My last 2 school districts, K-8, have 800 iPads deployed in one and about 700 in the other, as well as kind of the Google for Education domain of things. The little map up there, it only shows 2 points because the third one is actually too close for the scale to see it. But located not too far from Lake Michigan, which means when there's an opportunity to walk away because we're stressed, there's a 15-minute mindfulness walk to kind of come back, reset, and jump back into technology. When I was looking at this session and trying to think about what we had, there's a lot of things we can do when we want to monitor and alert on our systems. And when I started this bullet point list was both sides in 8-point font. And I know no one wants to read 8-point font at 9 a.m. in the morning. So I tried to summarize it a little bit and say when we're looking at everything we do with alerting, monitor, and logging, we're trying to find out what's happening and to let us know, because those are the fires that we have to usually put out right now. When we look at things of analytics and numerical data, we want to find the trends. And once we find those, we want to know how can we be ready for the future using them. And then when we look at this last one, kind of this log aggregation and taking all this information that all of our devices are putting out there, why did this thing occur, and should we be worried about it? And the worry doesn't necessarily need to mean a security issue, but just should we be concerned? Is this something that in the back of our minds we should note? I'm also going to try to use, this works out okay, I'm going to see how it goes. There should also now be a link on the top of these slides. These will allow you to, if you have a question, you can go to that URL, you can put a question out there. If others like your question or they have something similar, there's the ability to upvote that question, so that way I know, wow, 8 people want to have this question answered. I should make sure I tackle that one first. You can also, I believe, give your own answers. So that way, if you have the experience and you know the best answer for that one, feel free to contribute it out there. Have fun with it. But be, of course, mindful of the code of conduct for the conference. So there's tools that I looked at, and I picked 3 main open source tools around alerting with Nagios or Nagios, depending upon your syllable usage, monitoring our systems with Cacti, and then kind of doing log aggregation via the Elk stack. And that's a series of 3 different products from the Elastic company that manipulate data and let us do really cool things with it. There's, I think, 300 others out there. So like within that Google Doc that I shared out, you'll see a spot of if you're using something other than these tools, If you want to jot it out there, kind of we can take that hive mind knowledge or the mesh knowledge, kind of like a mesh network that's out here, put it out together. I like these because obviously they're free, so if you're in education, that's usually one of the best reasons to pick something. But it also means there really isn't an investment time other than the cost of your time to learn these tools. They let you run a couple of commands, get them installed. I believe there's a Docker image that installs the elk stack, so you can use that method to kind of deploy it and see the value and then go see where that fits in. And if you do have a budget and there's a pay tool that works out better, you've built that foundation and then you can kind of expand out from there. Thinking about alerting. When we think about alerting, what are we looking at? We're trying to identify that fire that's burning in the corner over here, and then inevitably there's another one that we kind of have to run to over here, and then like 6 more show up. But it's focused around really the current state of our operation and looking at service health or physical server health. One of the key things I found with this is using functional area notifications. You might wonder, what do we mean by functional area notifications? It means we're letting the correct people know about the issue that are going to be the best suited to fix it. We can do things and create structure, and I'm going to talk about that in a little bit and why that's important for making it easy to let people know. An example for that is if you have a virtual server team, they probably don't necessarily care that an access point might be down at the moment. They have a different focus. So you can make sure when you do these alertings, you send the notifications to the right groups. We all have alerting right now, right? We have somebody that sometimes gets frustrated, and I haven't had a computer go out a window, but I have had a voice over IP phone go out a window at work. It was resilient. It still was working, which is rather surprising for going down 2 floors and hitting concrete. If anyone wants to know the vendor, I will tell you afterwards. So if you ever run into that scenario and you want to know, does it fit a 2-story drop test out of a window? Yes, this one does. But we want to avoid this notification and alerting. We want to avoid the person picking up the phone day after day and telling us something's not right. So the tool with this one that I looked at was Nagios, and we have the ability to do things like create structure. We can take the physical operation and the physical layout of our network and put it into a logical arrangement. We extend with service commands, so rather than just looking to see is a server up or down, we can focus on DNS or DHCP or other services that are crucial to our environment. You can look at TCP ports. If you want to make sure port TCP 548 is available, you can do that. I don't know how much longer that one's going to be up and going on some of our devices, but the opportunity is indeed there. We want to make sure we define relevant alerting times and then some basic reporting abilities. Everyone loves code in the morning, right? Like you've had enough of caffeine to go through it. But before we go into the code of what that looks like, I just want to talk about the structure a little bit, because if you think about it, our network isn't just flat. Our infrastructure is not this one gigantic switch on the side of the wall that has 500 switch ports, every single server, every single device in it. Things are arranged. We have hosts, and those hosts have parents. Those parents can have parents even. What does that look like in our environment? What might this appear as? You might have a web server. Does anyone in here have a web server in their environment? All right, so at least this isn't like a foreign concept. We're familiar with web servers. If we follow a patch cable, that eventually goes into another device, and that can be a DMZ switch. And then if you follow where that's connecting, that most likely is going to have a firewall or something else in it. I like that because that takes the arrangement that we have on our network and it turns it into something that can look like this. When I look at this chart or this graph, this diagram, it actually doesn't look far off from some of the graphics I think that were on one of the arcade systems in the area. But we have that opportunity to look at this and get a really quick view on a structure. So we can see from the process that sits out there, we have on the right-hand side GCS 3750. That's one of our core switches, and from there we go out to our IDFs. Those are the 2960s. On the periphery, kind of those dashed lines were access points. I turned off the icons because this just looked horrible with that many access points on it. But it gives us a feel and a quick way to have an idea of how everything relates to one another in our infrastructure. We also have the ability to look at the view this way, that very hierarchical structure of where things are. I look at this right now and I say our two virtual servers, or VMs, transportation and iPoint, I need to move those and put those onto their correct physical host because they don't exist there in our organizational structure of device hierarchy. I now have alerts like this that can pop in. So I'll get a little red indicator that says when I'm trying to troubleshoot or find where there's an issue, click here, drill down, see the child devices, and kind of expand that out to make troubleshooting a lot easier. We define hosts. We give them a name, an alias, their IP address, and we assign the parent to them. We also can use these contact groups that focus around the area notifications, so that way we inform the correct individuals about something not working. Now, I talk a lot about structure because I think in a school it's kind of important. It's ingrained in you. You always have the structure of where things go. But you want to do this because our devices don't only exist in a physical path, kind of like that if you were to do a trace route, you'd be able to find all the spots a packet would go moving through our infrastructure. But we can do this to also put them around functional areas. So we can say all of our web servers are going to be a group. Everything that's building-based, everything that has a specific function. So I made a chart. I made a graph. This session has a few graphs in it and pictures, so if anyone here is a visual learner, you'll be able to kind of tune out possibly that code thing, send it to someone else, and focus on this one. But sometimes I want to arrange my hosts based upon a building scenario. Sometimes it's around function. It gives us, again, that structure to help troubleshoot a little bit. Once we have hosts and everything defined, the next thing that we want to look at is extending it with these service commands. And the service commands do the actions. They're the item that looks at this one, for example. This command is called check host alive, and it runs a ping on the host that is specified. Now, the host comes from the configuration, and I'll show that on the next step. We also pass in some parameters. If you think about it, we don't have kind of servers that exist in the, like what, Schrodinger's server scenario of they're both up and down until you actually go to check if they're available or not. We can set up tiered hierarchies that work through things like service health on this one of this host can be up, it can be down, or it can kind of be in this warning state. And what this one will do is when it runs a ping, it says if there's a 3-second delay or 80% packet loss, we want to say that that's a warning event. We can also say there's a critical threshold of a 5-second delay or a 100% packet loss. Right? Packet loss at, what, 9:15? Isn't this great? But some of these service commands don't always work out right out of the box, and we need to customize those a little bit. If we were to just use the check DNS one, all that does is it says we're going to go look at a host, we're going to make sure that DNS is running. We want to make sure DNS is running. It is important, but we do want to extend that a little bit. And instead, when we run through these commands, once you install all the plugins through Yum or whichever other repo solution you want to use, packages, whatever method, you can run any of the commands, in this case check DNS, and put in help. And it shows you here's all the parameters you can use. So you can specify, instead of trying to look at the DNS host that my monitoring server is using, I want to actually go hit our remote DNS servers. And then I can specify a host name to look up like Apple, include warning and critical thresholds that are important for DNS. That means when I run that command, for example, and I say I want to look at apple.com from the viewpoint of our 192.168.56.20 server, and I did use some kind of crazy warning and critical thresholds of 2 milliseconds and 10 milliseconds for DNS response times, but just to show that now this event, instead of saying DNS is okay or DNS is good, we get a warning because it took a little bit longer than our threshold value. And this can apply to all sorts of services, all sorts of commands. Once you create your commands, you assign them into hosts. So if you kind of think of that structure diagram again, we're proceeding into this stage. We have everything kind of arranged really nice and organized, and then we say on the things in building A, we want to run a ping on all those. We want to do the same thing with our email functions. But on the servers that have email functions, we could go and extend that and say we want to check SMTP on 2 of these because one is our filtering appliance. We want to make sure SMTP is able to receive messages coming into our system through our MX record through DNS. And we also want to make sure our internal server is able to receive messages from configured email clients. If you copy and paste or use this slide, please change my email address to yours. For your environment, because I probably won't be able to help you out if something in your environment is not working. But we define contacts, we define groups. I excluded my coworkers so that they don't get your notifications possibly. But the contact group here, admins, so if you're a really small shop, that might just be you. If you have teams that are responsible for different activities, help desk admins. Actually, if you have a help desk that can create tickets from emails, you can make that be a member of the contact group. So if there's a host down, or if you wanted to go as so far to check the SNMP value of cyan, magenta, and black toner in a printer, and then the system detects a printer is out of toner, it can then send an email to the help desk, which then could automatically create a ticket. Although I will say the one thing I've learned when working with printers is I could be sitting or standing right next to the printer waiting for it to run out of toner, and someone would still tell me before I actually was able to get to it. It's pretty much the only device, I think, within our infrastructures that people always notify us about before we find out. And then we want to define relevant alerting times. We probably don't want every single network device to alert us at 24/7. Right? No one actually here probably wants to be alerted 24/7 about devices. So you can create time periods. In this case, we're checking hosts that we do not shut down as a virtual machine. I don't care about them when they're turned off. Please do not notify me at 6 p.m. that the machine is not online. It shouldn't be. You can also tie these reporting times into things like SLAs. Best one I could think of as an example like that is, does anyone here have Cisco SmartNet? Does anyone love Cisco SmartNet? Okay. That's a service that allows us to have hardware warranty repairs. So if we have a 24/7/4 turnaround on a device like our wireless controller, that wireless controller is down, our wireless in our district is down. That might be one that I say, because I have a 4-hour turnaround window, if our controller were to not behave nicely, stop turning on for whatever reason at 10 p.m., as much as I don't want to receive an email or a notification at 10 p.m., with that 4-hour turnaround, you would have the situation of users don't experience any downtime. Depends on how much you love your users. Everyone loves their users a lot, right? So everyone should be doing that with those really critical devices. No, you don't need to. But then at that point, once you've run through all this, you kind of get a structure that looks like this. We have hosts organized into structures where they go, and we set up notifications. Now, an item I do want to put out there is, when you're putting a solution like this into place, make sure you also have some method to monitor your network or your device from outside. Because if you're only monitoring all of your services from inside and your public connection drops, you probably, A, won't be notified because you can't send the email out, and you may never see that there's a service down because internally your network's up and running. So if you could find other services to do that, if anyone here wanted to partner with someone else on that, you can monitor each other's servers. Also make sure you probably have, for some critical devices, the ability to notify an address that isn't within your domain. And because there's a question that's in this section, Jared asked, is there an easy-to-follow setup guide for Nagios somewhere? I believe there is a turnkey VM that you can search for that I think has 5 or 6 monitoring tools in place. I don't know what the name of it is off the top of my head, but if you were to search for Nagios virtual appliance, there'll probably be some solution out there that you can put into VBox or Fusion or any other tool. That was cool, right? I didn't have to throw the catch box around and spill coffee on anyone yet. We see some basic reporting stats. We get a quick feel for this host group we've made. How are things organized? How are things running? We know which buildings have good UPSs on their switches. We know which ones we might want to look at and see, do we need to replace any of these? You can also drill down into specific hosts and get an event log. It'll tell you when an event occurred and then when that was cleared out. So there are a couple of other reports as well, but these two lend themselves pretty well, I think, to projecting up on a screen. Fires. So that takes care of the fires, right? They're all put out. We can kind of move on to this next stage now of, it's great that monitoring can tell us that an access point is down. Let me switch that. Was it switch that, reverse that? Young Frankenstein? What's the quote from? No one knows? Okay. If you think of it, if you want to submit it, I'll put it up there on the big screen. Alerting will tell us that an access point is down. Monitoring won't. If it can't connect to an access point, it's not going to care. It's just going to say, oh, I have no data, and move on. But we can use monitoring to give us data about our infrastructure, like the number of connected clients on an access point. We can look at things like what's the bandwidth on a specific network port. You can do it on trunks and kind of really expand it out onto your network, and you can go really crazy with these. The device that we use, or the software, is Cacti for this one, and it's focused mainly around network devices. So this is going to be switches, routers, firewalls, access points, anything that sends numerical data out via SNMP. You can graph your basic trends. The nice part about here is it's GUI based, so instead of having to edit a configuration file or numerous configuration files, you click and you add a device. It's also really, really helpful because others in the community have shared great templates. So if you want to graph your wireless network, you can find if someone has put a template together for your vendor, and you don't have to do anything other than install a file. So it's definitely nice in that regard. I don't like going through steps again too often because it's boring. So I'm only going to put 3 in. You add a device, you specify the host name, the IP address. Please don't use SNMP Community 1 or a really obvious string for your organizations. It's just nice for the aspect of presenting at a conference. Depending upon your environment, you might need to talk with the network team and say, hey, can you make sure that the host that we're using is allowed to connect to SNMP on a specific device? Once you do that and you make sure that the information is correct, you then pull back all sorts of interface information. So on here for our switch, we see the VLANs that are configured. We see our port channels, our switch stacks, our physical interfaces, as well as the status, up or down. Let's say we find a really interesting network port. We say, oh, we want to know what's going on in it. It's a checkbox. You select the item you want to create a graph of, you select the type of graph that you want, and then step 3 is you profit. We don't profit. But we do have the opportunity then to start looking at really neat, informative data. But there's a problem sometimes with this data. Does anyone want to guess what this graph has wrong if I were to say, our average bandwidth utilization, or the capacity that we should have based upon the 95th percentile metric, is 17 meg. So the problem with this, right now, this is a week window, but I'm just going to shorten it down to a 24-hour time span. We're a school, so typically 8 a.m. to 4 p.m. is our hour of operation. Suddenly in a 24-hour window, 2/3 of that time period isn't indicative of our normal operation. If you switch it out to a week view, you're using 23.6%, 40 hours out of 168 hours in a week. So suddenly, using this metric to say 17 meg is approximate our capacity is being offset by 75% of data that doesn't matter for our environment because it's not its normal usage pattern. So kind of if you look at some of this, you want to keep that in mind that while we do have these graphs that give us great information, a 24-hour time scale or something that includes large chunks of time when we're not at normal utilization is going to offset that number. But you do have the opportunity to get cool things like this. Using one of those templates someone generated, I was able to pull out and display what are the methods people are using to connect to our wireless network. I was very happy to see we do not have any connections that have ever connected in a year on 802.11n and 2.4 gig. That would make anyone that probably handles a lot of wireless scream. Why are you using a giant channel? But we do see, if we were to say, let's see what happens if we turn off our 2.4 gig radios. We would see the chunk in green in here say, well, if this happens, I should be ready to turn that back on very quickly. Potentially because we're going to have a lot of devices that may or may not connect. I'm sorry about that graphic. I'll tell you what that's supposed to look like. The graph on the bottom shows the number of connected clients to a specific access point. And the graph up here, there, is the maximum bandwidth used. But now we're taking two sources of information. We're taking the sources that is the physical connections on our device. We're comparing that to the bandwidth utilization. And in this example, we found out that we only had a spike around 2 p.m. So even though in the morning 60 people were connected to this access point, there wasn't a lot of traffic going around. Most likely it was a phone or another wireless device that saved its network credentials. Someone walked in the door, it associated, but it wasn't doing anything. It's important to look at graphs like that of different sources, because some of the times when we look at that, we would normally say, uh-oh, we should put another access point in here because there's 60 connected clients, that's a lot. Does the data behind it, showing our usage, actually justify that question? What about custom data? So basic ones and switches are there. If you want to go crazy, you can look at manufacturer MIBs, management information bases, that specify SNMP values and OIDs, and this number represents black toner level. This number represents the page count. This number represents, through our temperature sensor or for our battery backup unit, the load or the runtime that's on the battery. So you can find these custom bits of data, input them in, and then pull out something that is relevant or important for your environment. If you're ever wondering, can you graph it? Can you get information from it? The first thing to look for is, does it have a network port? So if your battery backup unit has a network port or a management interface card, there's probably a good chance that, okay, I see there's potential here. And then you have to usually go to the vendor and find out, do you have that information available somewhere? Exciting. All right. I think this is the exciting part, because this is, we get to dive in a little bit deep here on how we take information from all our sources and analyze it and put together neat-looking metrics. Because we have our environment that's telling us stuff's not working. We've been able to get some basic data on bandwidth, for example. That's, I think, the easiest one out there because I think everybody can relate to it to pick. But what about when we want to get syslogs from devices? What about when our switch is telling us we've had an interface that resets? How do we work with that? And I know with logging, there's Graylog, there's Splunk, VMware has, I think, Log Insight as their product. There's a few others out there. And in essence, they're all doing the same thing. I picked this one because it was a great opportunity to learn, and every couple of weeks it's being updated. So it has a very active development community. And it focuses around a stack of products. So we just don't install the Elastic app. We actually install 4 different applications. We handle one Logstash that takes all the data that's out there and it pulls it in, and we then configure it. We use Beats because someone thought, rather than make you figure out a way to send log files from a remote machine, we're just going to write a little app that does it for you. Elasticsearch handles the search analysis, and then Kibana is the fun one because that graphs the data. The techie one is Logstash with configuration files. Kibana is the one where you make nice looking charts. The one beat that I want to mention is FileBeat, and we install this on an edge device. There are RPM packages. I think there's MSI deployables out there that you can use. The Mac version is an install package, which is nice. And we specify the log files that we want to monitor, the path that they belong to, and then it just sends the data. They also have ways to look at things like metrics on your machines. So if you want to graph the memory usage or CPU usage or disk activity, you can do that. You can use PacketB to do things that focus around network application data. In essence, you're doing a TCP dump and sending all of your network traffic back here so that you can analyze it. We can do the same thing with Windows events, and then another one that looks at service uptime, and that's the one that's shaped like the heart for heartbeat. Half of that's readable, so that's all right. That just looks bad. Anyway, the files that we have here, we configure on the left-hand side are file paths. So in this case, we're looking at a few called zimbra.log. We run failed to ban on our mail server. So we're going to pull in the failed to ban log. On the right-hand side, we have a little bit more of the Windows version. So we're looking at, in this case, Mail Marshals, the product that we use for our email filtering and archiving. The other part that's important to note on here is we use this tag on their document type. And that allows us to give us some meaning for the text that's going to come in later. For example, on the right-hand side, on the Windows one, because I think that's a little bit easier to read, we know one of these that we're going to look at is controller star. So any file in that path that matches, we're going to input that file type as a log file, and it's going to be tagged as a document type controller. That allows us to then work with that kind of in our next step. The best thing I can say about Logstash is it's probably one of those products that if you don't love it and you find it incredibly cumbersome to use and it frustrates you, it's going to make this entire process much less fun. It's a lot of text-based configuration files of inputs, filters, and outputs. A great tip I read on this is to initialize a Git repo in your config directory. As you work through configuration file changes, push and commit those somewhere. Has anyone here ever built like a 500-line configuration file, and then you have to find where in that file you have one mismatched right closing bracket? It isn't fun. It pretty much would make me, in that first slide I had with alerting, want to pick up the computer and throw it out a window. But instead, you can break these files down into functional mini configuration files, which makes things a lot easier. And don't be like this with Logstash. You do want to learn it and embrace it. Inputs. What are inputs? Inputs, what do they look like? They're the way that we use to ingest data from remote sources. So up here, there's 3 examples. 2 of them are looking at UDP ports, port 5514 and 5544. Because for me, this is running on a Linux-based machine, I am not using ports under 1024 because those are privileged, and I do not want to worry about running this with root privileges on my machine. We also use a Beats input, so we've configured that on port 5044. Once we do this, we also do need to configure our Cisco switch, for example, and say, you need to send your logs to this host using the UDP protocol and send it to port 5514. When that data now comes in, anything that comes in on port 5514, the system now knows this is a Cisco switch. The same thing with the firewall. I could send all this onto one port, or I can differentiate it out and make it a little bit easier to work with later on. There's a variety of other inputs. We can use files. Some network devices don't necessarily allow us to send their log file to a specified port. So in this case, I did a little manipulation through our syslog and said any file that's coming in on our standard syslog port from the IP address of our wireless LAN controller, put into a different location, and then read that file. What's nice about this modularity is as long as you can get the file in some manner and send it somewhere, you have the ability to look at it. There's also inputs. If anyone's using the AWS API, you can pull in data from that. You can pull in output of shell commands, GitHub webhooks, IRC, Puppet Factor. You can format CSVs. If you really wanted to, you could also set this up and configure an IMAP account. So you could have visualizations about your email. Anyone love to see like a chart of who's sending me the most amount of junk mail the last week and be able to look at the exact address and, oh, all right, I'm going to filter you into the trash. We use these filters because this line of text, we could probably figure out what it means if we look at it. But what do we do when we're trying to figure out why is this one IP address emailing us so often? How do you work with that normally? You might look at one giant log file and then do a find, and then write down all this information, but we want to make this meaningful. We want to be able to find key components of this and be able to pull those out to use later. And that's where the filters come in. They allow us to format the information that's out there. We can parse out and identify meaningful fields, and then with those, we use patterns and recognition to find what we want and reuse it. I mentioned breaking up configuration files into smaller chunks, and this is what I do. I use, it applies these in numerical order, and it means that when I forget or do something incorrect in 32-filter-ciscoap.conf, I know, because that's the only file I've recently modified, I bet I made a mistake in this one. You can use whatever system works out best for you. I would just say, don't create one giant file because I did that and then I said, I'm never doing that again. How do we do these patterns? We use our friend Grok. I was debating about trying to draw a mascot. Like if you had to visualize what Grok looks like, I don't think it'd be like warm and cuddly. Regex usually is not something that you're kind of like, oh, I just want to go and hug you, Regex. No one does that. We take patterns. What we do is the top line that came in was the message we received from our log file. This could be a syslog message that comes in from a switch, a firewall, an access point. And we construct a pattern. In this case, I hopefully got the color coding right and everything shows up okay up there, just to kind of show that when we use the pattern percent bracket number or curly brace, it's going to match with 15092. We use time. We use the literal PTR record for Pac-Man missing the rest of his head and only his mouth is here. And then we use client IP. So we're going to match the IP address and we're actually going to save this record. The first two, number and time, because we haven't specified a field value to store it in, we're discarding that. We're still going to have that appear in the main message, but we're not going to use it for anything. We work through some more lines of text, and we use, again, the IP match to find the from server. And then at the end, we say status. So this has taken this entire line of text, and now it has given us a client IP of where that message came from, the server that it says to be, and then what we did with it. This is useful because now that we have this information, we can work with it. So client IP turns into running a GeoIP lookup. And now that tells me, oh, here's the location that this IP address is from. So one line of text has now given me an approximate coordination of a GPS spot. That's how you have this one chunk of data that now turns into more meaningful data that you can kind of use later on. I'm going to show you why that's important. Don't worry. Filters. The same way that we build messages, we have the ability to do conditional formatting. So earlier on, it was port 5514 for Cisco switches, 5544 for firewalls. And we tagged those as a switch and a firewall. Now when that data comes in, I can say if the type is a Cisco switch, perform different operations on it. If you're starting out, you could probably look and say, well, I just want to take in two pieces of information and work with formatting it. If you build out any patterns or you have to create custom ones, building out the conditional statements makes it so that every line of text doesn't potentially need to go through 30 filters to try to find a match. It can go through just the 3 that are specific for switches. Has anyone ever tried to make a Grok statement or tried to work with regex statements? Has anyone done it without going to a website to use as a reference? I use them all the time because I never remember what they are. And if anyone wants to give this one a shot now, you can. It's grokconstructor.appspot.com, and you can paste in a line of text or multiple lines. I like this one because it walks you through the steps. It shows me what the options are for matching. And so it fit on the screen. I did a little ahead of time, but now it's telling me on the right-hand side, you'll see it says unmatched text. That's what I still need to work with. And then it gives me the potential patterns and what the resulting value would be. So I don't necessarily have to know, in order to match a DNS name, I should be using hostname. Much as I like that, I don't need to know that. I can use this tool to find that out for me. And you can step through it. So if there are pieces of the configuration that you want to use that are just focused around matching physical lines of text, capital PTR, a space, record, space, for, you can do that. One challenge, though, is how do we find meaningful data? How do we know what we're looking for if we don't necessarily know yet what we are looking for? And did anyone go to the Q&A session yesterday, just in the room right next door? I think Nick had mentioned with log aggregation, just get it. Have it in one location, because later on then you can start working through it to find out what is meaningful. If you're looking to know, how do we know, what does the log line entry look for from our system if we have somebody have an invalid email password? The best way to do that is go to your email, log in with the wrong username and password, and go watch for the line of text that comes up, because now you can use that data to find out, oh, this is what I need to look at. Same thing with if you're searching for disk I/O errors and you're wondering what's the actual verbiage that comes up. I wouldn't necessarily say do it with a hard drive, but maybe put a USB drive in and then just yank it out, and you'll get the little, untitled was not ejected correctly, close, dismiss. But then you'll get the line of text to know, oh, now I know what to look for. Now I can start looking at all this data and be clued into where we want to go. So inputs handle getting data in from all these different sources. Filters let us manipulate it. Outputs just send it somewhere. You can do that same thing. You can send data into, if you really wanted, and I would completely say do not do this, but you could send it into one giant index that never rotates, it only grows in size, and it has millions and millions and millions of lines of text in it. Or you can use the conditional formatting and say, if it is something coming in through FileBeat, for example, in this case we're sending it into Elasticsearch, we're sending it into the specified index, we're calling it FileBeat, and then we're going to dynamically put in the year, month, and date. That way I have all of my data chunked out by a specific date and time. The one on the bottom, if it's Twitter, for example, send it to the Twitter index. You can also output items to paths. So you can send it into, when you're building a configuration out, send it into a temporary file. You can then troubleshoot it a little bit. I forgot to put it in here, but there's a tool out there that works with this. So if you go that elk stack route, look at installing Curator. It's a plugin that works with the entire system. You build out a file and you say, look at FileBeat. And after 2 weeks of data, close the old index and delete it. So that way it automatically gets rid of old information. If you don't, you're going to most likely fill up the hard drive on whichever device that you're using. Or you will have a great reason to say, we need to buy more storage. There's a silver lining to everything. I don't have a lot on Elasticsearch because it's this little middle product that stores your data. The configuration, as we saw the slide before, really is send it here into an index. Here's what it's called, and then we're going to dynamically put on a date. It's the only product I think in this entire presentation has one slide. There's a line that they use on the website of Elastic, which is it's elastic.co, and when they talk about Elasticsearch, they say, discover the expected and uncover the unexpected. I'm like, okay, that fits. That really, oh wait, that for me fits more in the product Kibana that handles all the visualizations. What we're trying to do here is make the data that we are collecting from all these different sources meaningful. Because when you're looking through lines and lines and lines of text, there's usually nothing meaningful there. You can know that an event occurred, but you don't have a lot to work with. And it's built around search terms. So we create these search terms that work as filters because we don't want to look at 50,000 entries of information. We want to look at the 50 or 200 or 400 that we say are meaningful. We turn those searches into visualizations. That way we have a way to take the data of text and turn it into something. And then we can take all these different visualizations and put them together on one dashboard. The dashboards allow us to organize the visualizations so we don't have to go one by one and see what they look like. This is just a selection. Area charts, heat maps, goals, metrics. If you remember that GeoIP example, once we had a GeoIP location, we can now make a coordinate map out of that. So now we know where traffic is coming from on a geographical view. Right, what does this look like, right? Because that was a lot of talking. Here's a quick example that I pulled together a couple of days ago. It was looking at the last 4 hours. So you'll see on the top right-hand corner, there's that window. And we are using the type item. So remember I was saying, like, you can say something is a Cisco switch or a Cisco firewall. I'm not going to look at firewall logins on a switch because they're not going to be there. Instead of looking at all that information, I've narrowed this down, and I'm looking for anything that contains the word login. And I find in the last 4 hours on this date and time, there were 413 times something tried to log into a firewall. What do we do with that data, right? So now we know something occurred. Well, the message that came in was this. Login was denied, where it came into, where it was going, what port, protocol, and the user. Using those filters, I kind of then said, this is the stuff in this message that I care about. What was the action? Login denied. All right, good. We do want to see that. The source IP address. Where is this data coming from? Who's trying to get in or try to log in? Who doesn't know their password, possibly? The public IP that they're using. So now you can start looking at which machines that they're looking at. SSH, since we had the port information, as well as the username. I'd never thought about this until I had this visualization and was starting to pull this data, but this now told me, wow, if people are only trying to use root to log into my firewall, you know what username I should not use? Root, because people are trying to use that. So I can take this attack vector and eliminate a good chunk of it by pulling in what people are trying to do. What does that look like? So now that we've pulled all this data together, here's what we generate. We generate a chart, and this is a 24-hour window now, that looks at the attempted firewall logins. And it's pretty consistent at about 100 per 30-second window. Because we're able to pull out the source IP address, I have a pie chart that represents the top 5 IP addresses that are trying to get into our systems. That's a nice way to create a firewall rule and say, you know which IPs or subnets I don't even want our firewall to listen to? These 5. The bottom list is color-coded based upon our buildings. So we have 3 buildings, school colors, one's red, one's blue, one's green. And it's the number of times we have an access control list entry hit. The last item on the bottom is the port number that was being used. So now we have this chart that's telling us the number of times people are trying to telnet in, the number of times people are trying to connect in on port 1443. And it can span out as long as you would like. And all that information is coming from that one single line of text. VPN connections. There's another one out there. How many people are connecting into our VPN? This one uses a tag. So if you have a Cisco device or many other vendors, they're going to put in a tag that's going to say an entry that corresponds to the firewall for somebody trying to connect in with a VPN is this. You can also search for it. I was happy to see that the usernames were not all me, which is a very good thing. Switch events, so looking at network devices, kind of that same piece of if we looked at switches earlier, we would know is a network port maxed out by doing some monitoring. Well, other things that happen on switches are interfaces turn on, they turn off. We can take the information that's coming in from our switches, and in this case, you'll see on the top left, selected fields. Normally, when you run a search, you just get the entire message that comes up. In this case, we're pulling in what's the syslog severity. Do I need to be concerned about this? What host is it coming in? What interface? The status. And if you think about this chart, this is only looking at 4 hours, but a normal environment, you would probably see a pretty good spike in the morning because your switch ports would be going from down to up with somebody turning their computer on. When you roll in towards the end of the day, you would see the same quantity, but now these are going from a state of up to a state of down because people are turning their machines off. If I suddenly see a lot during the middle of the day, I might wonder, why are people needing to restart their machines? Did something happen? And we can turn that again into another chart. We can take all that data that's coming out there and say, show me the top 5 switches that are having, just in general, switch events that are happening, group them by the host that they're on, and then take that data and put it into buckets that correspond to the specific interface. So now I know from a switch port, wow, this interface is being turned on and turned off a lot. Why is that? In this example, these two, because this was kind of a neat testing scenario, the 2 ports, one of them is it's gig 1032, the one in green down below is 1022. I plugged those switch ports into one another. So they had the exact same number of events, 192 spanning trees turned on. So we're able to look at this and say if 2 of these are the same, which it would be, if you think about that, in a 4-hour window to have 2 ports on a switch have the same number of events occur is really unlikely. But it gives you a quick way to investigate that. And now the best part is I don't need to try to go into my switch to find out. It's sending me the data, I'm manipulating and working with it, and kind of turning it into something else. Email events. So we point this at our email server. And because what could possibly go wrong by pulling up what is going on to our email system while I'm here? If we look at the last 4 hours, here we've had 62 times that somebody had an invalid password, which actually isn't really too bad, and it looks like they just didn't have their coffee in the morning from the timestamps on those. But that data now turns into something meaningful, because once we have all of that, I'm going to pull up lower info because this does not contain information about our students. But now we aggregate all this other information together, and we probably want to see more than the last 15 minutes of data. Let's be bold. Let's see how long it takes to pull in 24 hours of data from our email system. All right, that wasn't too bad. Now we know, for example, on the top here, this is our filtering appliance. I would want to make sure that the rules with the most hits occur highest in our rule set order. Because if the last rule is going to catch the most messages, let's move it to the front. We can look at how often do email DKIM signatures match. So how often do we have the DNS and IP look how they're supposed to? What addresses are people sending email to that no longer exist, and how many of those? We have a little dashboard down here. These were the accounts that were locked in the last 24 hours. What's nice about this is these can auto-refresh. So now this turns into a dashboard that you can put in to help desk scenario. Because I don't know, does anyone know in Exchange, how do you find out which accounts are locked other than going into Exchange to find out where they say they're locked? Or if you're using a Google product or any other one, I'm able to pull that information and just make it accessible without having to go to multiple sources. I could find who's sending the most email. If suddenly the top 5 or 6 people, as an example, if I have a user and I know that they are our top email senders, I can just exclude them. So you can very quickly pull in some information. In this case, it's a minus on the glass to say I'm excluding it. So I can knock out our normal 5 or 6 top users, and now I get a better example of where's the email coming to that is not our normal high volume user. Likewise, do that as a from. You can kind of, at that point, find out, has someone shared their email password, because they should not be sending 5,000 emails a day. No one should. No one here is sending 5,000 emails a day, right? Okay, good. I can monitor that and put it up there as a chart. But I like this one down here. This is showing us now our email volume, and I'm going to exclude out our filters. We're going to look at all of it. Now we have this rolling 24-hour window that's just giving us a breakdown by hour of the number of messages we receive, how many are delivered, and how many are rejected. That insight is really, really neat and powerful. Hey, and none of that data blew up, which is good. When we have these entries come in, this might be a line we would see, and these might be the pieces we feel are important. When did they occur? We can start looking and seeing, did we get a lot of email around a specified time? We can look at where it's coming from. Wow, is one address trying to guess accounts? We could find that out because we can build a visualization that says, look at email coming from a specific IP address, and then sort it out by the individual user. Which protocols are we using? Was their authentication failed because they've used an invalid password, or was their account already locked? That dashboard, we look at the visualizations and you take and tie it to physical locations. Suddenly you're looking at, this one I think was some form of information. I don't even remember what it was. But now we've put in a heat map that's focused around, wow, we have a lot of traffic coming from, it looks like Google or Apple, and then something in Asia. Okay, why do we have that? We're a small school district. We can do things like this. So we can now pull in connections per access point. Now, I mentioned earlier, remember monitoring? You could do that. You could say, I want to look at the number of connections and create a chart for each individual access point. And then look through all the charts for 93 individual access points and find out which ones have the most traffic. Or I can run a command that pulls that data from our environment. I can format it as a CSV. I can say an input is the CSV that's giving us the access point name and the number of clients, and now use that as an input to show all of our access points, which ones are the heaviest. I don't have to go and look through the potential of 93 individual graphs. If you have an organization that is only domestics and you don't have anything going on overseas, so for us being a school district, we most likely don't have people traveling or people logging in from countries outside of the US. But this graph showing us the logins by country and state is pretty much coming from the fact that we can get a line of text that says, here's an IP address that authenticated. What might be more interesting is to take this graph and say, show me the valid email logins by country and state and exclude the United States. Why would somebody from overseas be logging into our email system with a valid password? And that might be a quick way to identify, has anyone possibly shared their account information or had their account password guessed, because Nacho seems like a great email password. I'm not joking, someone did use Nacho. Do we know why this event occurred? So for monitoring switches, that same thing of, wow, a lot of stuff happened. Oh, that's when we push new firmware to our voice over IP phones. Yep, we should see a spike in our network with events. If we didn't do something, okay, why is there a spike? Other examples, because I like living on the edge and pulling up live data in front of a room full of people. Hopefully not. As long as the wireless holds up and my VPN connection stays online, we'll be good. But there was that quote of, discover the expected, uncover the unexpected. How do you even find that out? Right? And the piece is, you take data, and at some point, you kind of have to do this. You kind of just have to look and say, all right, I don't care about our firewalls right now. I don't care about our switches. I'm just going to kind of look for some weird events. And this happens to work out well because there's this one down here. I really don't know what this means. You probably don't either because it's not that legible. Is that any better? I don't know what it means that we have a timeout communicating to the controller on a data plane. But now that I see something like that, I can take that term and I can search for it. Probably take a second or two, but in the last 15 minutes, this has happened 105 times. And as you'll see, this is 9:45 to, all right, so I have about 15 minutes left, I think, based upon the fact that that's around 10 a.m. Maybe I should restart this access point, right? I don't know why it has those up there, and I could probably go look, but you can discover this data that honestly is just sitting there and then figure out how to work with it. And I made another one. Every so often you get kind of a product and you find something and you get the like, okay, this is neat, this is fun. And then you get this extension of I would have never have thought to do it this way. And this was a great opportunity. Twitter can be an input source. So that means I can set up an API account for the Twitter streaming API, and I can say I want to pull in all data from the last, in this case, I'm looking at a 7-day window that's using the conference hashtag. So these are all the tweets in the last 7 days, 312 of them that are using the hashtag for the conference. We can kind of see the engagement go up as the conference has been going on. It looks like yesterday there was a lot of social media usage. But what can we get from this? Well, we can find out, for example, the user ID. So we can actually find out who at the conference here that's actively tweeting has the lowest Twitter user ID, because that would mean that they were a pretty early adopter. We're going to sort this by a different order. It's going to take a couple of seconds to run through some data, and we're going to find out that Tom Bridge, and of course he's a binary user ID, was the 11,011th user of Twitter when he signed up. You can find out who has the most followers. I wonder if it's going to be Tom again. So this is that weird fun data that has nothing to do with tech, but if you're a company that works with social media engagement, what if now you were monitoring Twitter for the times that people are saying, to be generic here, ISP cares. We'll just use that as the hashtag. There's a company out there and they use their name, cares. But now I can monitor my social media engagement of people having issues. I can find their time zone. So information that's out there, just in general, on your profile, suddenly becomes items that are actionable. So you can use that for like social media insight of, are a lot of people experiencing an issue in a specific geographic region? And I'm going to pull up, I made a dashboard of Twitter. All right, last 7 days. So the most popular client that people are using is Twitter for iPhone, with Tweetbot for iOS coming in pretty darn close as a second. We can find out that 43% of the tweets are coming from individuals in the Eastern time zone. We can filter, so we can click on this and find out of users in the Eastern time zone, they seem to currently like Tweetbot for iOS a little bit more. We have the word cloud below that's showing us, based upon the number of times the individuals have tweeted, they're kind of scaling the size behind it. If anyone wants to tweet something using the hashtag, don't feel obligated. I'm only going to give this two refreshes. So you do have the option to pull in live data. Right now there are, let's see if I can edit this really quick. Visualize. Number of tweets, refresh every 5 seconds. And eventually you would see that 5 seconds later this is going to update and pull that data in, which is rather amazing on how you can ingest data from all these streaming sources in a very short period of time. So if you see Tom, ask him, like, did you know you're the person at the conference that's using social media well here that has like been on Twitter the longest? You also run into things like this every so often. Initially, the source came up as HTML. And I don't want all that garbage around this. So I was able to use one of those constructors and fiddle with it and add a couple of characters before and after to find out, oh, this is how I pull out Twitter for iPhone. This is how I'm able to pull in the client. Now I have data that I can make meaningful. So again, there's gobs and gobs out there that we can just kind of work with. Dashboards give us consolidation of information that otherwise would be all across the network. The one that I pulled up with email was using our filtering appliance to look at triggered email rules. It was looking at the count of messages coming in from our actual email server and putting them all into one spot. You can reduce a lot of time searching logs for events because has anyone had a fun, short experience searching logs for things that happen? It does happen, but it's not necessarily the most fun of things. Once we have that data, we can manipulate it, and we can pull in things like which accounts are accessing email from outside of the US. No one's traveling. Let's look at that. Which domains do we send the most email to? And I'm going to throw this scenario out there. Has anyone used or heard of switch stacks? So you have like 4 or 5 physical switches that are connected in the back on a data plane, and you don't have them as physical individual switches. The 4 kind of look just like one. How would we know that one of those stack members has failed? Because if we monitor and alert the stack, well, the stack's still going to be pinging back, so it's going to appear good. Our monitoring system might not get anything because that switch might not have access points or phones or anything that an end user would receive an issue with and give us feedback on. So the dashboard is where maybe that fits in. You can monitor and search for the syslog entry around something along the lines of switch stack member failed. And now if I ever see a dashboard number where that number is 1, I know I need to go do something without having to walk around to all the different IDF closets and find which one has a switch that doesn't have the little activity lights blinking. There's 2 or 3 other tools. And these aren't as nice, but they're really meaningful, they're really helpful. iPerf. This is a little command line tool. There is a visual one called jperf, but I think it's probably one where you probably need to install like the Java 6 runtime on your machine in order to run it. It allows us to measure bandwidth between devices. And we set up one device to act as a server. In that example, iperf-s for server, -u for the UDP port protocol. And then the port that we're listening on is 12345. On the client device, we say we're going to be a client. We're going to send data to this server. We're going to specify, we're using UDP in this example. The port we're connecting to, we're going to run this for 30 seconds, and we're going to send 250 meg. The reason we like UDP for this is because there's no flow control. It really is measuring the amount of bandwidth that is going between these 2 devices. So if I'm expecting 2 clients to have a 100 meg connection between them and I run this, the output I might get is this. I might have packet loss, so I actually sent 298 meg, and my sustained bandwidth over that 30-second window was 83.4. All right, 17% overhead on traffic. I don't know, is that good or bad? But you can do this wirelessly. You can do it across building links. It's a great way to just measure how fast can I send data from point A over to point B. It is very command line, so it doesn't have a nice visual like we saw on those other tools. There's also Wireshark and TCP dump that allow us to capture network packets, filter them out to reduce some of the clutter. And we see on the image down here, let me blow that up a little bit, just a quick view of what are the protocols that are being used. We're seeing DNS, some TLS traffic. We're seeing that there's ARP, there's spanning tree protocol, HTTP. You would look at your DHCP offers. If you have non-secure web traffic, you can reconstruct the entire flow of the stream of data and then look at why something happened. It is a nice way to do a little basic troubleshooting out there that gives you pretty neat insights into your organization. So why do we do all this, right? Why are we putting all of this stuff together? When I thought about it, it really became that, and I think part of it's the reason we're all here, we want to improve a level of service that's out there. And everyone being here to learn more is a great example of, I want to improve, so I want to do things better. These tools allow you to find out about problems proactively so that you don't have to go find them. It allows you the opportunity to have meaningful data. So when a manager comes in, for example, and says, hey, I've got a question. You know what, the internet's the internet, or the best one, like the internet is down. Has anyone ever gotten that one? Like, yes, the entire internet is down. That's exactly what the problem is. But it lets us, through alerting and monitoring, have a quick and easy way to take what that person has said, that the internet, all of the internet is down, and look and say, well, all right, our switches are up. None of our DNS has crashed out. I don't think it's that. Let's investigate physical devices. Oh, there's an access point that isn't working. Maybe that's what it is. And really to try to discover data. Like a lot of the pieces that are out there for monitoring, our devices are giving us all sorts of information, quite honestly, all the time. So if we're able to look at that, pull it into a location, we can start searching for it a whole lot quicker than trying to search 10 servers, their system log, to find out what event occurred. They're all consolidated into one location. We can look for key terms in a very quick manner. And I think with that works out perfect, because the light in the back of the room says I have 5 minutes left, which is a good amount of time for Q&A. Like this one. Is it Nagios and Cacti creating all this data, and then you're using Elastic and Kibana to format it, filter, and display? So in these examples, we're using Nagios and Cacti just to alert and monitor. And then we're using Logstash, and then we're configuring that endpoint device. So a switch or a firewall, send your log files over here to this host. You can, there's probably a way to connect it all, but in essence, we're using the Cacti Nagios piece to say what's up and running as its own thing, and then we're sending the data over to Kibana and all that to format it. Did that answer that question? I hope so. And I guess I should ask, are there any questions anyone would like to ask with the catch box? No? Oh, all right. I'm gonna walk it because there's 4 minutes and I don't feel we need to throw it quite yet.
I don't want to knock my laptop off the table either. So with all this data going into one box, what's it called? Logstash on one box. And how big is this box, and how do you have it configured in your environment?
That's a great question. It's a VM that's running on a host. I think for us, with the number of devices we have, it's a 250 gig virtual disk. We do clear those files out after 2 weeks. I'd have to think that it might be 12 virtual CPUs, so if you're sending a lot of data to it, it's going to crunch a lot. The nice part about that, though, is if you have a pretty decent machine behind it, it just chugs along. And I guess those 12 virtual CPUs it's 12 CPU cores. You can run it if you don't have a lot of data on a smaller machine. It just might take a little bit longer to process some of the visualizations. But for getting started, I think I started this out with 8 CPU cores and 4 gigs of memory. So it can run pretty lightweight if you start small, and then you have to kind of scale up. It is dispersed, so if you needed to, you can spin up additional nodes and then put them into a cluster so that you have other machines that can go ahead and do that. Sure thing. Oh, another one. Good.
So how does Logstash deal with Apple's new logging, where there are no log files? It's all going to a database.
That is a great question that I do not have an answer to. And I wish I did.
I do too.
I'm trying to think, I don't want to speculate because I'm not sure on how it would work. The ones that we currently have that we've monitored, we'll just pull in, and part of this is probably being in 10.12, just the system log that's out there. I don't know how that log database style handles it, or if you can configure that to the database itself to output somewhere else.
Yeah, it's tricky. So maybe there's another class on logging later. Maybe they'll answer some of those questions.
I hope they're able to answer that one then for you. Any others? Oh, perfect. Well, if there's no more Q's, I have no more A's to give. I'm going to say thank you for attending. I hope it was a worthwhile session that everybody liked, and enjoy the rest of the conference. Thank you.